Let's start. Hello, everybody. Welcome. Thank you for being here. My name is Robin, and I'd like to begin this talk by sharing with you a little story. It's the story of our project in FluidWeb. And the story starts at the end of 2019. So at this time, our client, it's Siemens, they approach us and they have this cool idea. It's an ambitious and exciting vision where you go on their website and the content that you see is delivered according to a machine learning model that gives you content based on who you are. So the idea is that you go on Siemens.com and you're a healthcare professional. Then you'll see content about the latest health content, like medical imagery machines. Or if you're a software engineer like me, maybe you'll see content about their latest automation software. So they come to us with this idea, and it's a big challenge. But we accept it. We're up to the task. And then for the next few months, because we don't have a solution yet, we start exploring, we start experimenting. We have all these workshops where we explore ideas, we try out new things. It's fun, a lot of discussion. And then a few months later, we finally have a proof of concept model that works. So it's a recommendation engine that gives you AM content based on what you visited earlier. And sure, it's not perfect. There are still many things you can improve. But we have this model and it's working. And we trained it using data from the analytics and from content published by the authors. The last thing we have to do is to automate all the process because we did it manually, and then we'll be good for production and mission accomplished, right? Let's go home. And it was an easy operation, right? Well, not exactly. Why? Well, to understand better, I would like you to think of our machine learning model as an apple pie. So say you want to set up an apple pie business. And after some experiments, you find a good recipe for apple pie. And maybe you can improve it, but you know what ingredients you need. You've cooked it multiple times in your kitchen. It's not that hard. But if you want to scale up the process, you need to do a whole lot of things. You have to automatically bring all the ingredients together, process them, remove the bad apples. You have to comply with food regulations, and so on. Not so easy, right? Well, it's the same for a machine learning model, except here, our ingredient is the data. And you need lots of it. And there's new data every day. So then you start asking yourself all these questions. How do I store the data? How do I process it? How do I train my model with this new data? And so when all these questions arise, this means that you have to build a data pipeline. And that's what we'll be talking about today, how to build a data pipeline. So today I'll try my best to share the knowledge that we have acquired in the FluidWeb project regarding data pipelines. And my goal is that ideally, at the end of this session, you have a broad understanding about what is a data pipeline, how to build it, what you should consider. So let's start. So yeah, we can start with a definition. A data pipeline is an automated software system that collects the data from multiple data sources, transforms it, stores it, and uses it for delivering insights or training a model. But if you're like me, a definition doesn't help you that much, and I much prefer visualization. And here's a rough graph of the architecture of a data pipeline. And you can see that usually you have data coming in, answers coming out, and in the middle, you store and you process all this data. And there is also an iterative process between storing and transforming. So let's take a look at each step a bit more closely. And first, we have the ingestion. You need to get your data in your pipeline. The issue is often that this data comes from multiple sources that you don't always control. And each of these sources can be different. It can be It can be events, it can be a stream, it can be an export from a database, it can be in multiple formats. So you have all this consideration. That's the first step, ingestion. Then, once you have ingested all this data, you need to store it. And you can also see that the storage is connected to the transformation, because when you transform data, you also need still to store it. So here you have many possibilities. Just to name a few: SQL, NoSQL, Hadoop database, HDFS, each with their own pros and cons, but you always have storage in data pipeline. And when we're talking about storage, very often you'll hear about data lakes and data warehouse. So it's nothing to be afraid of, but what's the difference? Well, in a nutshell, the data lake is usually where you will put all the raw data, all the unstructured data. Usually everything you ingest goes in the data lake, but it's not very structured. It's where you put all your stuff. It's easy to put it there, it's cheap, but it's not easy to use. Whereas the data warehouse, usually that's where you put the processed and the structured data. So it doesn't always have to be two different solutions, but I think it's important to know what a data lake is and what a data warehouse is. And then the next step, transform. So you need to transform the data to make it ready for usage. For those who are familiar with it, it's kind of ETL, extract, transform, and load operation. So that's where you do, all the operation, cleaning, filtering, transformation, enrichment, aggregation. So sometimes it can be a challenge if you have lots of data, say hundreds of gigabytes that you have to process. In this case, maybe you want to use distributed computing to make these operations faster. So transforming. And then the next step is actually using this transformed and processed data to get something useful out of it. So that's where you make statistical analysis, where you compute metrics, or where you train your machine learning model so that you get insights from your data. So this step is not present in every data pipeline. Sometimes a data pipeline is just ingesting, processing, and putting it somewhere else. But in the FluidWeb project, we have this step. And one thing that is important is that your computation step is only going to be as good as your previous steps, as your processing was. Because there's a saying in machine learning, garbage in means garbage out. So if you have data that is not clean, that has errors, that has irregularities, this step will have problems. And last but not least, consume. So once you have all your insights, your model, your metrics, then you want it to be consumed. So this can be through a microservice, an API, a dashboard. So that's the rough overview of our pipeline. You can see all the steps. And hopefully you're thinking right now, Robin, this is amazing. How do I get started? And of course, you want the right tool for the job. So you get started, and if you do a bit of research about what to use, maybe you'll come up to graphs like this, presenting you all the possibilities. And there are many tools, many services, many frameworks, APIs. And chances are you'll feel overwhelmed, and who wouldn't, right? So to be honest, I don't even know half of the names in this image. My point is just that if you ask me which tools should I use, I can't give you a definite answer because there are so many and I don't know all of them. But where maybe I can provide you some advice is how to choose the right tools when building your data pipeline. And so when you're building the data pipeline, the first thing you should do is to ask yourself the right questions. First, what kind of data are we dealing with? So as I said earlier, it can come in various forms. Does your data need a lot of processing? Is it prone to errors? Is it structured, unstructured? Second, what volumes are we talking about? I mean, if you're ingesting megabytes of data per day or terabytes, you're not going to have the same infrastructure. Third, what will you be using the data for? Uh, so if you use the data to train a model, then it will not be the same that to provide live analytics, for example. So you have to ask yourself, what's the requirement, what's the use case before you start doing anything. Another important thing, is latency an issue? What do I mean? Well, if you get new data, does it need to be processed right away? Or can it wait a few hours or even a few days? So my point is, in short, you need to understand the data you're dealing with. One thing that you might often hear about when reading about data pipelines are batch processing and stream processing. So batch pipelines and stream pipelines. The concept is pretty simple. The batch pipeline is executed periodically. So maybe once every hour, once every day, once every week. Whereas the stream processing, it's a different paradigm. It's executed all the time. So when do you use each one of them? Well, it depends on the use case. Typically, you'll use batch processing for use cases where you don't need the data to be processed instantly. So compared, to stream processing, it's often simpler to implement because you don't have to worry about things, such as queues, messages. Often in batch processing too, your data operations are easier to do. Say you want to do an aggregation or a count, it's much easier when you have all the data at the same time. But of course, batch processing can be less efficient because stream processing, you only process what comes in and that's all. So you have these two approaches. I won't go into too much details about them, but you should be aware of them. It also may be the case that some pipelines have a mixed approach, but you should know what batch processing and stream processing is. Okay, my second advice, when building a data pipeline, start simple. So as I showed you all these tools before, it can be tempting, to just start building and to get this framework for the storage and this framework for this other storage option and so on, with the hopes of having the perfect solution on the first try. I would rather advise that you start simple with your data pipeline and that you improve over time, because you'll probably run into some challenges that you did not expect and you don't want them to come all at the same time. And it's also very important when you do this to treat all the steps that I showed you as separate problems as much as possible. So treat the storage question differently than the processing question or the ingestion question. It will also be easier in the future to upgrade them, to maintain some parts, or to reuse them elsewhere. And my third advice is embrace the cloud and go serverless. So unless unless you have a good reason not to, use the cloud. Personally, I have some experience with AWS, so I cannot talk about Azure or Google Cloud. But my experience has been really positive with AWS. Because it's often cheaper, it's often quicker to get things to production. But on top of that, on top of using the cloud, I would also advise you to use managed solution. So go serverless. It might be cheaper in operational costs to rent a server and to run some open source software on it. But once you do that, you start to have to manage operating system updates, all the stuff like this, where you will lose a lot of time and you will lose a lot of focus about what you want to do with your data. And that's what you should focus on. So use serverless and get to production faster. And if you're worried to get trapped in an ecosystem and in proprietary solutions, most of the time, at least AWS, you have a lot of integration with open source softwares where that matters, such as Hadoop, Spark, Kafka. So and of course follow cloud best practices. So you want your solution to be scalable. in terms of increase or decrease in the load. You want in the load. You want decoupling so that each part is separated, as I explained earlier. You want reliability so that if one part breaks down, you have a backup plan. So that's my 3 advice when you're building a data pipeline. 1, build only after careful evaluation. Ask yourself the right questions before doing anything. 2, when you start doing anything, start simple. Don't shoot for the stars at first. I mean, shoot for the stars in the long run, but in the beginning, start simple and use an iterative process and improve and learn. And my 3rd advice, go serverless. Cloud solutions will save you a lot of time and hassle. You don't need to reinvent the wheel. So with this said, let's get back to the beginning. What does our solution look like? So we won't have time to go too much into details about the solution we developed, as much as I would like to. But just to get you a quick overview, we ingest the content coming from Elasticsearch and Adobe Analytics. As a data store and as a data storage solution, we use Amazon S3, which is cheap, reliable, efficient, even if not the quickest, but it's not a problem for us. We use Amazon Glue to transform the data and Amazon SageMaker to enrich the data. And then the computation part is done using Amazon Personalize, which is Amazon's solution for recommendation engines. And once our solution is retrained, then we make it accessible through a GraphQL API that can easily be consumed by the front end. So there's a lot more to say. I mean, we are using infrastructure as code, automated deployment, and so on. And I think it's really interesting. But unfortunately, I don't have time to go too much into our solution. One thing that I would like to do, though, is to mention the team that I've been working with for more than a year now. So many amazing people from the FluidWeb and the AWS factory team. So for the data pipeline, I mean, a special mention to Martin Lehmann and Jens Lauterbach, who have been a huge part of this data pipeline we've built. But of course, all the team, because we have this data pipeline, but by its own it's worthless. And it's only a small part in a bigger project. So big up to all my colleagues. So yeah, we're coming to an end. What have we learned so far? First thing that you have to remember, a working machine learning model, it's only a fraction of the effort. It's your recipe, not your automation. And the data automation and getting it into production, for me, that's the big deal. Second thing, be smart, think twice, build right, inform yourself before building anything. Then start small and improve and leave room for improvement. And my last advice would be, go serverless, at least in the beginning. And maybe you can make it less managed in the future if you have good reasons to, but embrace the cloud. And we're already coming to an end. So that's it. I hope you enjoyed this presentation. If I caught your attention, feel free to join us at the Applied Intelligence community. We have a lot of great minds and a lot of great discussion. And that's it. So if you have any questions, I'll be able to answer them, hopefully. So who should we contact if you want to join a machine learning project? I would say you have to, join us in Applied Intelligence community. We have a lead link, a great lead link, Angela Fabregues, which might also give you advice because she's the one, leading our Applied Intelligence community. So that's about it. So can we have both supported at the same time? Is it necessary to have MSc before starting to work on machine learning? So MSc, I assume this means MSc, I assume this means a master in computer science, maybe. I don't think so. So yeah, do you need to have yeah, like machine learning diploma or anything? In my opinion, not especially, because I mean, you know, the math stuff and a lot of the machine learning, it's important, but as I said, it's your recipe. And the big work around it, it's infrastructure, it's automation, it's programming. And I would not say it's a piece of cake. I would not say it's a piece of cake, but this is especially, I would say, a lot of programming and a lot of solutioning. Of course, having knowledge in math help, but it depends in which part. If you're doing pure machine learning, sure. If you're doing infrastructure, I think it helps, but it's not mandatory, in my opinion. Other question, would you recommend starting with Comprehend or SageMaker? Depends on what you want to do. So Comprehend is really a managed solution. For those who don't know it, Comprehend is a managed solution for natural language processing. SageMaker, it's a less managed service, but it's a machine learning platform that AWS provides you to build and to train and to experiment with your machine learning models. So to answer your question, would you recommend starting with Comprehend or SageMaker? If you want to integrate natural language processing in your project, if Comprehend does the job, I would say start with it, because it will be much easier to put into place. But if you want to have something more custom, where you cannot use an existing solution already, maybe SageMaker might be the way to go. Other question, is all this only for Python developers? Well, I would recommend to have some knowledge in Python. Also because I think it's a great language and I love it. But a big part of it is, I mean, Python is in my opinion, not the hard part, because the hard part is building the right solution, using, you know, the right tools, using the right services. And yeah, sometimes you have to use some Python, but it's not to do the complicated stuff. It's only sometimes, you know, to trigger something or yeah. So you most of the time having Python helps. It's not the difficult part, and you won't have to do like extensive Python programming, or at least I haven't had to. So are we selling machine learning solutions to other clients? And is this related to Smart Editor's Toolbox? So yes, I cannot speak too much for other clients, but I know that in other accounts they have some ML solutions that are being sold. And is this related to Smart Editor's Toolbox? Yes, absolutely. Because for the Smart Editor's Toolbox, you want to integrate your solution. You want to integrate machine learning in your solution. And for this, you need a data pipeline. So yes, it's related. Okay, so we're coming to an end. So it was fun. I hope you enjoyed this. And cheers, guy. Have a good afternoon.